I hope all of you are doing well. I did want to talk a little bit about the difference between teaching and coaching. What is the difference between going over how to do a math problem, what steps you take, and what coaching is? Because if there's no difference, then you're just a math teacher. Why do you refer to yourself as a math competition coach? And so I'm going to show you an example of what that looks like. This is something that I do in all of my classes. This is a snippet of one of my classes I had earlier today. And I really liked some of the things that I was saying in that. And I wanted to share it with you so you could get an idea of what that looks like and perhaps what classes with me are like when you take them and what benefit they might provide you or your student or child that you have. Let's get started. Before we do, I did have another announcement really quick. There are some discounted classes that I wanted to mention to you. First and foremost, my Saturday live streams have relaunched. You can go look at that. I'm going to show you really quick again where you can find it. This is my live stream platform page. It is linked in the description of this video. It had some technical difficulties, and I'll probably explain this in a separate video. But for now, the important thing is it has relaunched. You now can sign up. It does work. These are just $5 an hour classes. I mean, I don't know what less I could ask for and make it as economically feasible for you as I can and still be able to make a living as a teacher, as this is my full-time career. I don't work for anyone else. I just work in this way and earn a living by teaching. So having said that, the next one is tomorrow on Saturday, the 22nd, actually probably today now that you're watching this, and it will start at 3:30 p.m. Pacific. It has a free 7-day trial. So you can sign up and see, hey, is this worth my time? Again, if you are lower intermediate, you haven't yet qualified for Amy, and you're trying to learn how to do this kind of math versus what school math is, this is ideal for you. Anybody who's beginning or lower intermediate, anybody in that range, I'm going to be going over in depth a lot of concepts, strategies, different ways to look at and think about problems and how to utilize them, even the older tests on future contests. Okay, so that has restarted. The other thing that you might be interested in is these discounted classes that I am starting ASAP. Ideally, by about the second week of April, they will finish before the November tests. They have a graduated rate. So the normal rate for my classes is $50 for a 1.5-hour class, approximately $30 an hour. However, if 5 students sign up for either of these two classes, in that class, the one that has 5 students, every student will receive 20% off, which would be only $40 for the 1.5-hour session. If 10 students signed up, and I won't allow any more than that in a class, maybe up to 12 is the max that I allow. So if there's up to 10 or 12 students, all the students will pay $30 per 1.5 hours, which is only $20 an hour per student. And you're going to get high quality instruction during that time. I go very thoroughly through the text and I make sure that students understand everything there is to do with it. We don't just do selected problems, we do all the problems. And so usually what I find is that students who go through a class like this, I get reports that they've never heard it taught better than that. They've never understood it as well as I explained it and as well as their understanding is after going through my class as compared to other classes. So the classes are Thursday and Friday from 6:30 to 8 p.m. I could switch the titles. It just depends. As of right now, I'm defaulting to Intro to Counting and Probability. This is Pacific time on Thursday, and 6:30 to 8 p.m. Fridays is Intro to Number Theory. If you could please share this information with your math clubs, relatives, cousins, people like that, even people overseas for the live streams, $5 an hour is super inexpensive. I'm trying to be able to provide high quality instruction to people who generally can't afford, classes with smaller group sizes. And so I'm trying to be able to meet that need. Again, please share that. If it's successful, I will add other content to the live streaming platform that will also be similarly discounted to like $5, $10 an hour or less. Okay, so that is it for now. let's get to the difference between teaching and coaching. For Sally has 5 red cards numbered 1 through 5 and 4 blue numbered 3 through 6. She stacks the cards so that the colors alternate and so that the number on each red card divides evenly into the number on each neighboring blue. So if she has 5 red and 4 blue, start with that. What does that look like? It says the colors alternate. Could it start with blue? Blue, red, blue, red, blue, red, blue. You're out of blue and you still have 2 red. So clearly you can't do that. So instead, what you'll do is start with red at your base, alternate there's your 4th blue and your 5th red. And then in red, you have 1, 2, 3, 4, 5. And in blue, you have 3, 4, 5, 6. This problem is really about organizing your thoughts, creating a picture that looks like this or similar. Could you go sideways? Do you have to label it R and B? No, maybe somebody makes spaces and they put R here, B here, and they go across that way. Right? Stacks the cards is the same as laying them out in a row. Okay? So there's a bunch of different ways you might set it up, but the important thing would be you freaking did something. You made an effort. You tried to put this into some organized structure of thought. Okay? So she stacks the cards. The red card has to divide evenly. What is the sum of the numbers on the middle 3? First, that would be these 3. I mean, you can think about what it means to divide a number. Are there any numbers among the blue ones that are hard to divide? Are there any numbers among the red that automatically divide everything? Like 1? Like 1 is a really good number, but 5 only has 2 divisors. Because 5 is very limited, or numbers like 5 here for red, it only divides that 5. Therefore, if you put a 5 right here, it cannot divide this number and this number. That's impossible. It's not just the one above it, it's both the next door numbers. All of this is thoughts that you conclude as you think about what's going on. There isn't some rule in mathematics or algebra that teaches you this other than properties of division. I mean, you might have to ask yourself, does 5 go into 3? No, it doesn't divide it, right? You don't get an integer, which is what means to divide. So since you don't, you know this is true. Yeah, you were taught that, but how to solve a problem like this? It's not just, off the top of your head, you ask yourself questions. Where might this 5 go? What can 4 divide into? Oh, look, 4 only divides 4. What about red 3? It has 2 things to divide. 2 and 1, lots of things they divide. You have 2 very restricted numbers for red. And all it takes is asking yourself, what might this divide into? And I honestly don't know if you're taking this test. I may put this, by the way, on my channel, this part of the video, just to explain this kind of thought process at some point in the future, just letting you know. That's why I'm not going to use your names. But when you look, all it takes is asking yourself, does 3 divide into anything in blue? Or what does it divide into? Does 4? Does 5? And if you're reading a problem and it says each red card divides evenly into each number on the neighboring blue cards, it says that, and you're not asking the question, what does 5? I mean, what kind of questions are you asking? What did I eat for breakfast this morning? What kind of car would I like to drive? I mean, you know what I mean? It's kind of like we really need to just ask ourselves questions, asking yourself a question during the test. What does that mean? And then test. Does it mean this? I think it means that this number has to do something, right? I think it means 5 has to go on the end. Now ask yourself, challenge your own thought. So you argue with yourself a little bit during problem solving. You say, is that really true? What else could 5? It only divides into this. Guess what we just identified? Not only does it only divide that, this must be the blue 5. Nothing else can go there. We also know 4 has restrictions. You put 4 on the other end to be restricted, and the blue 4 must go here. Now, what red number has to go next to the blue 5? That's really all there is to it. A red 1 must go here. It's the only other divisor that number has. As a result, now here you might have said 1 or 2 must go here. But since we now have placed the red 1, immediately red 2 has to go in this spot, and nothing else can go by logical deduction. And finally, we will be right back. Free jokes. We get free jokes here. Okay, so BRB, what's going to go there? Mark off what you've already taken out. Red 2, red 4, red 5, red 1. Blue 5, blue 4. What's left? A 3, a 6, and a 3. Your sum will be 12. Now, should you just circle 12 like I just did on your actual test? Answer, no. What if by some weird quirky fault, your brain informed you something here that seemed really true when you said it to yourself? You're like, oh, let's say that you're like, 3 divides 5. And then later you're like, wait, why would I have thought 3 divides? What was I thinking? How many times have you had that experience? So many times, right? So many times that you can't even count how many times you've done something like that. Neither can I. The price of being human, it's evident in all of us at all times. So don't just go, look at how smart I am. I crossed everything out. It must now be 12 because those are the only numbers left. I'm a genius and I never make mistakes. No, you're arrogant, egotistical, and you're going to get caught one of these times on a question when your brain farts. So it doesn't take much time to go, what might 2 go into? 6. It's the only one left in the blues it goes into. What red card would have to go here? 3. Well, blue card here, does it work? 1 divides 3. 300% it works. Now it's the difference between I am confident it is 12 and I know it is 12. There's a huge difference between being confident it is 12 and knowing that it is 12. That's why it takes freaking 4 or 5 seconds to check your work. Just plug the numbers in and make sure that they will work. What if you plugged them in and it didn't work? Guess what you just found out? Something in your reasoning here and here is a problem. You made a mistake. But you don't catch that mistake because does the brain tell you when you're making a mistake? Not really, right? You just do it. And then you find out later, what? I got that. Oh my gosh, I forgot to consider. I can't believe. How do I? You know how you did it? You didn't check your work. That's how it happened. That's how it happens for everyone. You check your work and you make sure this is how you want to create. I know I'm right. Knowing means essentially you've proved you can't be wrong. And if you're not taking the chance to do that when it takes 5 to 10 seconds more, you're not doing this. Honestly, you just don't want to qualify that bad. That's really what it means. So when you say, why didn't I qualify and why did I make 4 sillies? It's because you didn't want to qualify. Well, no, I do want to. For sure, I do. Well, if you did, you would have checked your answers on those problems, right? Yeah, did you? No. Okay, well, then you didn't want to, right? And so this is kind of what you want to train yourself to think like. And that way, when you're taking the test under the pressure of time, do I want to qualify or not? Then I better just quickly check. You're looking for the opportunity. It's a reframing of the thought process. You're reframing the way that you think in order to see, is it possible I made a mistake? And I'm trying to train you right now to do that. Okay. All right. I'm going to clear screen and go to the next problem.